Hi everybody, welcome back to chemistry class. Today we're going to learn about the relationships between pressure, volume, and temperature for gases. So just a reminder, temperature is defined as the average kinetic energy of the molecules in a sample, and pressure is defined as the force over the area at which it's applied. And those two are directly related, because the higher the temperature, the faster the molecules are moving, the more frequently and the harder they're colliding with the walls of their container. Now, to demonstrate that, right here I have an egg that I have trapped inside this bottle, and I just can't seem to get it out. It's too big. I don't know what to do. Yeah, I do. So, in order to get it out, first I'm going to have to get it so that it sits nicely the bottom of this, so it's nice airtight seal. You can do it. You can dream. You can do it. Okay, so now I have my egg right there. In order to get this out, what I'm going to have to do is I'm going to have to heat up this Erlenmeyer flask. And when I do that, it's going to cause the molecules of air inside of this to be moving faster. And when they do that, they're going to exert a higher amount of pressure on the inside of the egg than the air outside is pushing in. So here we go. Please don't crack. You can see that the egg is working its way down the neck of the Erlenmeyer flask. And I will soon have it out. Okay. As you can see, the increased kinetic energy of the molecules of gas inside the Erlenmeyer flask were exerting enough force to overcome the atmospheric pressure pushing on the outside of the egg and allowed me to get the egg back. So, pressure and temperature show a direct relationship, meaning that when you increase the temperature, you are going to increase the pressure inside. You also could observe that the volume inside the container expanded. The gas wanted to take up more space, so it expanded as you increase in temperature. These are both direct relationships, and when you look at how the equations are set up, the volume initially divided by the temperature initially is equal to the volume at the end divided by the temperature. The temperature and pressure, the initial pressure over the initial temperature is going to be equal to the final pressure over the final temperature. All right. These demonstrated both. This is Charles' law and this is Gay-Lussac's law. Now we're going to look at a relationship between pressure and volume, which is an inverse relationship, meaning when one goes up, the other goes down. In order to demonstrate that, I'm going to use this pump right here, and I'm going to pump the air out of this container. Right now I have a crushed bottle of soda inside there, and this will explain, or Boyle's law will explain what you're about to observe. Right now, as I'm removing air from the container, the bottle is expanding. If I let this keep going, it would actually be enough to let it explode. I don't want to do that, make a mess of this stuff. So, but you can clearly see that the volume expanded when the pressure was reduced, because there was air inside the bottle that had a certain amount of pressure, and it was competing against the atmospheric air pushing on it. As I remove the atmospheric air pushing on it, the pressure from inside the bottle allowed it to expand against that vacuum. Now I'm going to let the air back in, and you'll see that the bottle got crushed by the atmospheric pressure pushing on it. So we could see the inverse relationship between pressure and volume. So as the pressure was reduced, the volume went up. So our initial pressure times our initial volume is equal to our final pressure times our final volume. And if you graph that, it would look like this. Because if you have a high pressure, you're going to have a small volume. If you have a low pressure, you are going to have a higher volume. And I want you to notice the difference between the graphs of these. So Charles' law, which represents volume and temperature's direct relationship, shows that as you increase the temperature, the volume goes up. Gay-Lussac's law shows a direct relationship between temperature and pressure. As you increase the temperature, the pressure goes up. And Boyle's law represents the relationship between pressure and volume and shows that as you increase the pressure, the volume goes down, and if you decrease the pressure, the volume goes up. So this was the introduction to Boyle's law, Charles' law, and Gay-Lussac's law. Next time we're going to learn about the combined gas law, which is what we get when we combine all of these into one equation.